Okay, this is about a very small job. This is about the need of doing some kind of modeling, which is a need that probably most of you have. The proposals can be just for research, for planning, and or any other objective. The issue is that usually the thing starts with I have some knowledge of the landscape, of the planning, I have some kind of biological data, and I know that I will need some data about climate and other stuff, but probably I might do it. So let's say that is your dream or your need. In this case, probably you are thinking on simulating for the future some kind of test. You are thinking on some kind of projection. If you are thinking that the conditions then will imply some different concentration of CO2, water supply, or many other things, or different management, probably your geotables are not so good as you believe. And probably you need some kind of ecophysiological model. So this is really a kind of model that gives us many opportunities. So if we put hands on the job, you probably can find some kind of nice packages of software. Some of them are, for example, this one, Landis. This is a quite complex model, not individual-based model, but landscape-based model. Is a court-based, and that you can run this model for a huge landscape if you want. You just need time. You keep searching on the web, and you will find that you have lots of extensions or options. This is nice because you have a lot of plasticity there. You can select all you want. Well, not really all, but most of the things. We have been listening today about the importance of fires or pests or something like that. Management is essential for our forests. So we will just find some kind of packages here. And don't forget that we need the ecophysiological module or extension or something like that, because we are running our landscape for a situation that we don't really have now. So the architecture of Landis is quite easy. We have a core engine that is on charge of the loading databases or loading raster files with some information about the ecoregions, the local conditions of each pixel. You have also, this is the responsible of loading many data about the species and many features about the landscape. You will be adding some other extensions there about which are ruling the growth of trees, which are ruling the disturbances, the impacts, the harvest, and stuff like that. So it's really, if you want, impressive, and it's nice. But it's quite complex. If you start working on this, you will first try to find all your extensions or your modules, well, not your, but the modules you are interested in, and so you can pretty accurately replicate your situation, your landscape. This is a common situation in the Carpathian Mountains, the type of modules that you need. Fire is not really essential. Most of the areas are not really affected by fire. But you can have winds, insects, harvest is quite important, and you will have some modules about the output data, some module about aging each of your cohorts in the pixels, so that your forest can be getting older, and quite nice, complex, but nice. This is not so nice. We start to see just the complexity. We have many of things to insert there. We need many sources of data, and you will be picking information from everywhere. One of the problems problems is that you probably don't have information for all your whole phase. So you will be inputting new information. You have to predict it, or you have to replace those missing data. Random forest has a crucial role there. I found that this is a very good tool for predicting landscape features. If you have good information, you can predict forest types, you can predict many things. So it really works there, and it really works good. But this is the picture. Probably that you will also need some kind of downscaling, climate downscaling more than 500 years, because you are working with mature forest, and you will have there probably trees more than 500 years, so you will have a big data series that is challenging, but it's nice. The problem is with the ecophysiological data. This is the real problem here. So we were already using the artificial intelligence, but we have the big problem with the ecophysiological data. So the ecophysiological data, because of the huge amount of missing data that you have, because of the high error of the measurements, because the data are taken locally, and because of many other things, you will find that your model probably won't fit, or you just when working perfectly for a small unit, then at the landscape level it crashes. It's not working really. So from these recommendations, this is the one. But we don't want to do that. So how we can solve this mess? I was telling you that you need lots of information, lots of parameters that you can't measure. Because sometimes it's just experimental information that is, requires a lot of effort. Sometimes it's some kind of data that is mostly theoretical. So it's not that easy. So if we look at the closet of the artificial intelligence tools, we have the genetic algorithm. It's just like with the genes. We can design several chromosomes. It doesn't matter that they don't really fit our final result, our objective. Some of them will just crash. The model won't work. So these are out. Other models are quite good, but not that good. And probably are not the best ones also. So we can probably skip them also. So we are just taking, making use of the ellipses. We are taking the best models. We can combine with other models. Well, sorry, not models, the chromosomes. Each chromosomes will be formed of many places, of many genes. Each one of them will be for one of our missing data. This is the secret. This is the funny thing. And also you have mutation. You can change information from one pixel or to another, or just, let's say, totally change some random value. And so this is like with the genes. We have the selection, you have the recombination, you have the mutation, and so we are applying this to our data. But how? I just chose the real values way. Every gene is a real value, so you just are randomly changing it. Well, you know the tool. If you need some binary information or categorical, is also useful, because depending on the values, you can then check it to binary data. So it's nice. It just works. And the challenge that is coming now is just for every simulation, you have to copy your folder with all the information in other place. Probably you have to modify 6 or more files, which are TXT files with well, it's structured information, but it's not that easy, it's not an Excel table. You modify them, you then call the terminal, you run the software, you can print lots of results, you will be picking some type of information and you're comparing it with your results. The problem is that you will be doing this for probably 1,000 chromosomes, and you will be repeating this for 100 generations. So it's quite nice. Obviously, you can do this at the landscape level. You will do this with some pilots. You can do that kind of simulations for the half of Spain or so. Even for the complete model, if you take the mistake of doing it really complex, you will need probably years to complete one single simulation. And you need more simulations, you need many simulations. So you just start picking some pilots and you are running continuously until you reach the results. This is a very, very small example, some kind of information that provided this type of algorithms. We have ecological data, ecophysiological data is essential, and you can also introduce some genes for some key parameters for ecoregions. For example, some kind of measurements like the routing depth that you couldn't get from inventories or so. And at the end, you can reach really nice simulations that probably don't fit perfectly what are you thinking of. Because this is the Carpathians, probably with the climate change, the precipitations in several areas is even increasing. Winter is not so bad during winter, let's say it's shorter, and the production will increase. So you can say that this is probably the projection, and you don't really know that will exist. I would say here that the next inventory was just confirming that our results were okay. Even when we have to use information very detailed about the management, about every kind of thing that you can think of, the results were really fitting the next inventory, so it's really nice. About just bullet, that the consequences of climate change in many of the scenarios was just an increasing of the biomass in the forest. The scenario that was really different was the intense climate change. The RCP, the representative concentration pathways, the 0.5 differentiates really from the others. So among the good points of this kind of model is that with this kind of tool you get reproducibility, and you probably will have a good fit, and you will have consistent scenarios. So I think this is one of the solutions for many of your problems. Okay, as I said, probably is the computation. Really demanding